Welcome to this next lesson, which is on more complicated algebraic fractions. So you're not actually learning any new theory this time, you're just practicing adding and subtracting fractions and multiplying and dividing fractions, but where it's actually quite a lot more complicated and might require a lot of factorizing and simplifying to get your final answer. So let's recap what we learned about fractions in Year 7 before we start. So let's just read through this. Fractions, addition, find a common denominator, common denominator, your LCD. Add the numerators, but keep the denominators the same. That's what sometimes I notice people don't do. Keep the denominators the same. So work out your LCD. LCD equals 6. Keep the denominators the same. Keep them 6 and 6. So your final answer is 4/6, which simplifies to 2/3. Subtraction, same thing. Find a common denominator. LCD. Subtract the numerators, but keep the denominators the same. Very important. So once you've got 6/8 minus 8/8 over 4 minus 4/8, that gives you 2/8, which simplifies to 1/4. So don't forget to keep your denominators the same. Multiplication, no need to keep denominators the same at all, completely different to addition and subtraction. So first of all, if you do have any mixed numbers, like 2 and 1/6, change it to an improper fraction first, 13/6. And the way they did that, if you're not sure, 2 and 1/6 is 2 times 6 plus 1, gives you 13/6. That's how they changed the mixed number into that. Not that you need to do that in this unit, but it's still useful to practice. Multiply, so once you've got your things, multiply the numerators, and then multiply the denominators. And then you don't need to do this, it's not necessary. Improper fraction is fine. So multiplying is super easy. Division, change any mixed numbers into improper fractions. Same thing, like 9 1/3. 9 times 3 plus 1 makes it 28/3. So change into improper fractions first, and then you need to keep, change, flip. And then you multiply the numerators, multiply the denominators. And then simplify if necessary. So keep, change, flip for divide. Okay, so now we've done a little recap. Let's go on to the examples on the next page. So again, these are nothing new, but they're just more complicated versions of ones you've had in the previous 2 lessons. So now let's try some more complicated examples of the 4 operations: add, subtract, multiply, divide, with algebraic fractions. Notice in my examples I actually don't have any divide in there, sorry, I forgot to put some divide in there. Okay, but let's just do the multiply, subtract, and add ones. So write as a single fraction just means combine it. You're not asked to solve or anything like that. You're just asked to combine the fractions and simplify them. So this is subtraction. So remember on the warm-up, the first page, we need to find the LCD first. Lowest common denominator of 5 and 3, that's right, it's 15. So we need to write them both so that they're over 15. So over 15 minus over 15. What do we need to times that all by? We need to times it by 5. So go 5 brackets, x minus 1. Minus, what do we need to times 5 by to make 15? Times it all by 3. 3 brackets, x minus 2. Next step, what you should do is you should, I would expand, because you're going to have to add the numerators. So I would suggest you could collect the numerators first, if that helps. In fact, that might be better. Feel free to do that if you like. It might be a bit more straightforward if we do that. So by that you might be wondering, what am I on about? I mean, go 5x minus 1, then it's subtract, so minus 3x minus 2. This might avoid errors due to forgetting to factor in the negative. And now you might want to expand. This might avoid, as I said, this might avoid some errors, because a common mistake is people will think it's minus 3x minus 6, but it's minus 3x plus 6 when you expand it. So doing it this way, combining the numerators first and then doing the expanding, might be a very good idea. So let's do the first set of expanding. First set of expanding, 5 times x gives you 5x minus, common mistake, people will think it's minus 1, but 5 times negative 1 is negative 5, minus 3x. What's negative 3 times negative 2? That's right, it's plus 6. Common error is people will say that it's negative 6. And now we just need to combine like terms. Combine like terms. 5x minus 3x gives us 2x. Negative 5 plus 6 is plus 1 over 15. Then you need to think, can we simplify this at all? Like, is it possible to factorize the top at all? No, there's no common factor in 2x plus 1, and nothing cancels out the 15. So that's our final answer for that one. So let's give it a little circle there. And the next one, just bear with me. Okay, so back to here, the next one. Next one, we've got 3x over x plus 2 minus 1. So we need to write them both as fractions. Think of 1 as just 1 over 1, if that helps. So 3 over x plus 2 minus 1 over 1. What's our LCD? Our LCD equals, have a think, that's right, it's x plus 2. So we need to write them both as being over x plus 2 minus something over x plus 2. So the first fraction already is over x plus 2, so no need to adjust that. But 1 over 1, so to make the red denominator become x plus 2, we had to times it by x plus 2. So do the same to the top. So the top becomes x plus 2. That makes sense. X plus 2 over x plus 2 is just 1. Now we can combine our denominators. Remember, as it says on the previous page, keep the numerators the same. Once you've got your LCD, and once you're up to the subtraction step, keep the numerators the same. Don't change them. So, sorry, keep the denominators the same. Did I say numerators? Keep the denominators the same. So don't change it to x plus 2 minus x plus 2. Keep it as x plus 2. Denominator stays the same for addition and subtraction. So we can combine the numerators. 3x, you might want to do this, minus, this might help, minus all of x plus 2 over x plus 2. Because a common error is they're definitely going minus x, but they're forgetting that the negative gets factored into the 2 as well. So when you factor the negative into the 2, you get 3x minus x minus 2, all over x plus 2. So doing it that way might help avoid forgetting to factor in the negative times positive 2. Some people would have written instead 3x minus x plus 2. And now we can just combine like terms with 3x minus x. That's right, that's 2x minus 2 over x plus 2. This is totally fine as an answer, but you can also have an answer written with the factorized version of the numerator. So 2 brackets, x minus 1. Can you cancel anything down? No, you can't. So let's circle. So it could be that one or that one is fine. You'll probably find in the answer they have this one in the answers in the textbook. Just because, I don't know, it's easier to have the factorized form. You probably do want to factorize it in order to see if you can cancel down anything. So that's why they'll tend to have the factorized version, the red version, in the textbook. Now let's continue on. Let's extend our page. And let's do these doozies. What do we have here? Oh my goodness. So we have multiplication. So it's going to be multiply the numerators, multiply the denominators. But you really probably should factorize them all first, because when you factorize them, you'll probably find you can do some cancelling down first, which is going to make your life so much easier. So they're quadratics. They're the quadratic on the top and the bottom, quadratic on the top and the bottom. They're all just simple quadratics, so you can double bracket straight away to factorize. You don't need to do any splitting methods. So let's go straight to factorizing these lovely things. So our first one, you've got to think, so what I mean is like do this kind of thing. Over. So x plus 2 plus x minus 2, you have to think to factorize. What's two numbers that multiply to give negative 2 and add to give x? So add to give 1. And by 1, I mean because it's 1x. So multiply to give negative 2 and add to give 1. And so two numbers that multiply to give negative 2 and add to give 1, would you agree are 2 and 1? Sorry, positive 2 and negative 1. So positive 2 and negative 1. Because 2 times negative 1 is negative 2. 2 minus 1 is just 1. And if you FOIL that, the blue expression that I have in the numerator, if you FOIL that, you'll actually get and combine like terms, you'll get x squared plus x minus 2. And the one on the bottom, have x squared minus 4. That is a quadratic that can be double bracketed. What kind of quadratic expression is that? X squared minus 4? Have a think. That's right, it's a difference of squares. And how do you factorize a difference of squares? Number one's a plus, one's a minus, and the other is just the square root of the 4. X plus 2, x minus 2. And what's great is you can already see from the blue algebraic fraction that's been factorized, you're already going to be able to cancel down x plus 2 over x plus 2. But I'm going to do my cancelling down later on. So times, I'll do the other one in green maybe. I'll do it in blue. Let's keep it in blue. X squared plus 3x minus 10. It's a quadratic that factorizes. Normally, you don't need to use the splitting method or anything. X and x. So think, what's two numbers that multiply to give negative 10 and add to give positive 3? Give you a chance to think about that. Two numbers that multiply to give negative 10 and add to give positive 3. If you've had a think. That's right, it's plus 5 and minus 2. Because 5 times negative 2 is negative 10. 5 minus 2 is 3. So those two things is where it came from. Then the bottom one, x squared plus 7x plus 10. Write out your double brackets and your x. What's two numbers that multiply to give 10 and add to give positive 7? Have a think. That's right, it's plus 5 plus 2. Brilliant. Now we can do our cancelling down. So remember, we can cancel a pair either diagonally when we're multiplying fractions, or we can cancel a pair vertically. So I'm going to cancel these ones vertically. So I'm going to do that with green. X plus 2 on the left and an x plus 2. It's going to cancel down. Can I cancel down anything on the fraction on the right? Have a look. I can cancel down an x plus 5, which I'm going to do that in a different colour just to show the pairs of cancelling down I'm doing. I can cancel down an x plus 5 and an x plus 5. So we can cancel down pairs vertically. We can cancel down pairs diagonally as well. Is there anything I can cancel diagonally now from what's remaining? Have a look. That's right, I can cancel x minus 2 and an x minus 2. Remember, we can't cancel horizontally when multiplying fractions. We can cancel pairs of factors vertically or diagonally. And now our answer is just what's left behind, which is brilliant. See, it's very simple now. X minus 1 over x plus 2. We don't have to write the brackets. It doesn't simplify any further. Fantastic. And so it's amazing that that big complicated expression in the question became a nice simple fraction in the end. And next one, moving right along. We've got 2 over x, x plus 1 over 1 over x plus 1. Got to think, what is our LCD? Those come in the denominator. Have a think what it would be. That's right, it would be x brackets x plus 1. Which makes life easy because the first one is already over x brackets x plus 1. So let's write that, 2 over x brackets x plus 1 plus, what do we need to times the second fraction by, the top and bottom by, to make x brackets x plus 1 the denominator? That's right, we need to times by x. So times 1 times x is just x over x brackets x plus 1. Fantastic. So we've times the top and bottom of the second fraction by x. Now we can combine the numerators. Remember, keep the denominator the same. When adding and subtracting, keep the denominator the same once you've got the LCD. So our new numerator will be 2 plus x all over x brackets x plus 1. So we've just got to think, is that our final answer? Can we cancel anything down? No, we can't cancel anything down. So that's one possible answer. It's not necessarily wrong if you had the expanded version, 2 plus x or x plus 2 over x squared plus x. That's just where you expanded the denominator. The textbook will tend to have this answer because the factorized version is the best one to use to see if we can cancel down further. So that's this page finished, which is brilliant. Now let's go on to some really tricky ones on the next page. right here. So now we have 2x over x plus 4, and we also have minus 40 over x minus 1, brackets x plus 4, brackets. We've got to think, what's our LCD? LCD. So have a think what it would be. That's right, it's just going to be x minus 1 times x plus 4. So the second fraction already has the lowest common denominator as its denominator. So we just need to adjust the first fraction. What do we need to multiply the top and bottom by to make the lowest common denominator the green denominator I put over there? That's right, we're going to times it times by x minus 1, x plus 4. Now what am I saying? That's wrong. Just times by x minus 1. So we've already got x plus 4 in the denominator, so no need to times by x plus 4 again. So let's write it like that. So it's going to be 2x, we need to times it by x minus 1. 2x has to be multiplied by x minus 1 in order to make the new denominator. And so, just one sec. 2x, x minus 1, all over the lowest common denominator, x minus 1, x plus 4, you might just want to write kind of narrowly here because it's quite long, minus, minus in blue, so it's pretty clear what it is. And then the second fraction is already over the lowest common denominator, so no need to change anything in that. It's already over x minus 1, x plus 4. You might want to combine the numerators now before you do any expanding. So perhaps go 2x brackets x minus 1, don't forget to subtract, so minus 40, all over, keep the denominator the same. Adding and subtracting fractions, keep the denominator the same. Now you might want to do any expanding that's available. So 2x times x just gives you 2x squared. 2x times negative 1 gives you minus 2x, minus 40 over our LCD, x minus 1, x plus 4. Now, don't FOIL or anything, no need to expand the denominator, because in order to simplify, we're going to have to factorize anyway. So I would avoid expanding. We only expanded in the numerator because we had to collect the like term, we had to subtract 40 in order to combine the equation. What we need to do now is we need to factorize the numerator to see if anything cancels out with the denominator. So first thing I would look at is there just a common factor? 2x squared minus 2x minus 40. Yes, there's a common factor of 2. Let's do that first. 2x squared minus x minus 20. Always good to factor out a common denominator first. Now, what's left in the red bracket in the numerator can actually be factorized. It can be turned into a double bracket. So don't forget the 2 is still there. Really crucial you keep the 2, but you can double bracket out the numerator. So we've still got x minus 1, x plus 4 as our denominator. So now, what's two numbers that multiply to give negative 20? So they multiply to give negative 20 and add to give negative 1, because that's a negative 1 there. I'm just going to do that. So multiply to give negative 20, add to give negative 1. Have to think, what's two numbers? Multiply to give negative 20 and add to give negative 1. That's correct, it's negative 5 and positive 4. Because negative 5 times 4 is negative 20, and negative 5 plus 4 is negative 1. Now that you've factorized everything beautifully, you can see whether you can cancel anything down. We can cancel x plus 4, x plus 4. Can we cancel anything else down? No, we can't. So our answer is just going to be 2 brackets x minus 5 over x minus 1. And it's finished. Not necessarily wrong if you wrote it as the numerator as 2x minus 10 and the denominator at x minus 1. But the answer will tend to have it in the factorized form. So perhaps you want to practice doing that. And then that one's finished. Good working out there. So this next one's pretty mega, and it's quite wide. So you might want to write reasonably narrowly. And when I worked it out, I have about 4 lines of working out. So you might want to write reasonably small, particularly thin, because you've got a lot to write out horizontally, if that makes any sense at all. So you've got x over x minus 1 over x over x plus 1. What's our LCD? It's going to be a pretty big one this time. So the only LCD you can get is x, brackets. All you can do is just times all 3 of them together. There's no other simpler one. So like that. That would be your LCD. That's why it's going to be so wide, because you're going to have 3 fractions written out in the first line, and all of them have that LCD. So let's write that all out now. What colour will I use? I will use purple. So what do we need to times the first fraction by to make the denominator x, x minus 1, x plus 1? We need to times it by x brackets x plus 1. So that's a bit awkward to write out. So I tended to go straight to writing x squared, x plus 1. But I noticed some of the students like to do this. So you can do this if you want. X brackets x plus 1. Double close brackets. Or actually, do you know what's even better? Just do this maybe. X plus 1. All over x minus 1, x plus 1. You see what we did? We just took the first x, just multiplied by x and x plus 1, because that's what was missing. And then we can expand that in another line. What you might want to do as well is we might want to separate out this so that we don't get the questions mixed up. Then it's minus, let's see, minus 1 over x. So we need to multiply the top and bottom by x minus 1, x plus 1 to make the LCD happen. So 1 times that is just x minus 1, x plus 1. It's easy enough. Over x brackets x minus 1, x plus 1. And then it is plus. Do I need to multiply the top and bottom by to make the LCD happen? I've got to multiply it by x brackets x minus 1. So like in the first fraction, you might want to do this. X minus 1. X minus 1. That might help you out a bit. And now maybe let's combine the numerators. I'm going to do all my expanding as well, if that helps. Okay, so what we've got to do is we've kind of got to go like x times x times x, because in a way this all becomes, if it helps you, rewrite over this, x times x is just x squared. That might help you out. X times x is x squared. That's what I did in my first step, but now you can see why. Now what we've got to do is we've got to expand this bit. So x squared times x is x squared. X squared times 1 is, sorry, no, x squared times x is not x squared. X squared times x is x cubed. X squared times 1 is plus x squared. Now what's awkward is the next step is going to require some foiling. So I'm going to do foil, 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 but I'm going to do minus all of that first. So it's going to be subtract all of the results of the foiling. So put it in brackets. X times x is x squared. X times 1 is plus x. Negative 1 times x is minus x. Negative 1 times 1 is minus 1. And because it subtracts all of this bracket, that's why I've used the bracket. The next is plus, so it's not so hard. Plus x squared times x is x cubed. X squared times negative 1 is negative x squared. And that's all over our LCD. X brackets x minus 1, x plus 1. And now I'm going to do this bit. You could combine like terms in the brackets first, like plus x minus x just cancels out to be nothing. But there's no, I'm running out of space, so there's no harm in doing it like this first. So we've still got x cubed plus x squared, but then it's minus x squared when you expand that, then minus times x and minus x, and my negative 1 times negative x, so plus x, then negative 1 times negative 1, so plus 1. And then we've just got what's left outside, plus x cubed minus x squared, all over x minus 1, x plus 1. Now I've got to combine any like terms. So you might find x squared minus x squared cancels out there in the numerator. What else cancels out? Anything else cancel out in the numerator? Let's see, yeah, negative x plus x cancels out. Does anything else cancel out in the numerator? No, it doesn't. So now we just combine like terms in the numerator. So the like terms in the numerator will give us x squared, x cubed plus x cubed is 2x cubed. Just a second. 2x cubed. Sorry, I just have to pause and close the file and open it again. Thank you. I've just paused and opened the file again. So something a bit funny there then. So what we're doing is we're rewriting out the numerator. So we've got x cubed plus x cubed, 2x cubed, and we've got a minus x squared and a plus 1. And our denominator is just x minus 1, x plus 1. Notice that the numerator, it's not a quadratic, it's a cubic. At this point in our course, we're not expected to know how to factorize cubics, just quadratics and linears. So at this point, this is allowed. And so for example, the answers in the back of the book would just accept this. Nothing cancels out from the bottom or the top. Because at this point in your course, you're not expected to understand how to factorize a cubic like in the numerator, whether it could be factorized or not. So now we need to scroll down and do this big doozy on the bottom. So this is a huge doozy. To be honest, I probably needed to give you more space. So please write small. It's a multiplying one, and the reason why it's so hard is you need to factorize every numerator and every denominator. They're all quadratics, but they're not ones that can just be split into double brackets immediately. You have to use the splitting method to do all of the factorizings. So I'm going to do 4 lots of splitting methods, and I'm going to set them up on the right. So you might want to separate off a column to show you working out. You might want to separate off a column, and this column on the right you might want to divide into 4 equal rectangles and try to fit your splitting method into each one. So you could, like, split it up like that kind of thing, just so you realize how to set your working out up. I'm not sure if you write bigger than that, but if you can write small, it's going to help you a lot. So I'm going to do the numerator of the first fraction first. So the first step, just so to help you out, let's write it out. 2x squared minus x minus 3. And remember to quadratic factor one like this. The reason why we have to quadratic factor using the splitting method is the value of a, like the coefficient of the x squared term, it's greater than 1, and there's no common factor in all 3 terms. So that's when you have to use the splitting method. So go a times c, maybe you work out ac first. A times c is 2 times negative 3, which equals negative 6. So what's 2 numbers that multiply to give negative 6 and add to give the middle term? So we're going to split this middle term, like the coefficient of the middle term, sorry, the x term. So it's 2 numbers that multiply to give negative 6 and add to give negative 1, because it's negative 1x. Have a think. That's right, it's negative 3 and 2. So we now split that x term into negative 3x plus 2x, because negative 3x plus 2x is just negative x. So we haven't changed the expression at all, we've just split the middle term. So minus 3x plus 2x. So see what we did? We split the middle term, negative x into negative 3x plus 2x. Then we do factorizing of 4 terms, like back in Unit 1, a quadratics unit. So that will become, what's the common factor of 2x squared minus 3x? Have a think. That's right, it's x. So you're left with 2x minus 3. Then factor the second part, 2x minus 3. What's the common factor? It's just 1. So plus 1. Remember, our brackets have to be the same, which they are, 2x minus 3. So the result is 2x minus 3, and the remainders go into the other bracket, x plus 1. So again, hopefully you managed to fit that into a box. I'm writing it up pretty big because I'm writing on the smartboard with a thick pen. But you try to shrink them up a bit so that you're going to fit 4 of these splitting methods on 1/2 of your page. this question anyway. Because then we're going to need to use the column on the left to do the fractions and to cancel down. Next fraction I'm going to do is, next quadratic I'm going to factorize is the denominator of the first fraction. So the denominator of the first fraction is 6x squared plus x minus 15. So we've got to do AC first. AC equals 6 times negative 15. Have a think, what's that? That's right, it's negative 90. So it's two numbers that multiply to give negative 90 and add to give positive 1, because it's positive 1x. Have a think. That's right, it's 10 and negative 9. So we're going to split the middle term, the x term, into 10x minus 9x. So 6 squared, x squared plus 10x minus 9x minus 15. So again, we haven't changed the expression, we've just split x into 10x minus 9x. Now we can separately factorize each part. 6x squared plus 10x, we can take out a 2x, which would leave us with 3x plus 5. Negative 9x minus 15x, we can take out negative 3, divide out negative 3, leaves us with 3x plus 5, and then our brackets are the same. So our factorized version is 3x plus 5, and the remainders go into the other bracket, 2x minus 3. Brill. Now we've just got the other fraction to do. So the other fraction, we've got the numerator. I'll start with the numerator of that fraction. 4x squared minus 7x plus 3. Again, first step we have to do is to work out AC. Sorry. Extend the page a bit. Let's work out AC. AC equals 4 times 3 equals 12. So it's two numbers that multiply to give 12 and add to give negative 7. Have a think. That's right. It is negative 3 and negative 4. So split that term, 4x squared minus 3x minus 4x plus 3. So we've split negative 7x into minus 3x minus 4x. Then let's factor each side separately. Highest common factor of 4x squared minus 3x is x. So we've got 4x minus 3. Highest common factor of negative 4x plus 3. Just take out negative 1, because that'll make the bracket 4x take away 3, because it has to be the same bracket in both. Same variables in both. Same expression in both brackets. 4x minus 3, x minus 1. So that one's done. And we've got the last one to do. So the denominator of the second fraction, 4x squared plus x minus 3. And third is in purple. Oh. Back. 4x squared plus x minus 3. First thing again we have to do, what do? That's right, we work out AC. So AC equals 4 times negative 3 equals negative 12. So it's two numbers that multiply to give negative 12 and add to give positive 1, because it's positive 1x. Have a think. That's right, it's 4 and negative 3. See how much work this problem is, it's huge. So we're going to split the middle term, 4x, the middle term of x, we're going to split into plus 4x minus 3x. Because plus 4x minus 3x, it's still just x. So the overall expression hasn't changed at all. Then we separately factorize each side. Highest common factor of 4x squared plus 4x is 4x. So we're left with x plus 1. Highest common factor of negative 3x minus 3. We need the bracket to be x plus 1, so factor out negative 1. So divide out negative 1, leaves you with x plus 1. So our final answer is x plus 1, 4x minus 1. So the whole point of this was now we can rewrite the fractions in their factorized form. The numerators and denominators in their factorized form. It's brilliant, because then we're going to be able to cancel down. So the numerator of the first one was in blue, so that becomes 2x minus 3, x plus 1. That's from this thing here. Next one in purple was the denominator. This was over 3x plus 5 brackets 2x minus 3. There's a multiply sign in the middle. The numerator, the second fraction, 4x minus 3, x minus 1. 4x minus 3, x minus 1. And the last one, denominator of the second fraction was down here. X plus 1, 4x minus 1. Oh, just 1 second, hang on. Am I that right? X plus 1. Sorry. Wait, what did I do wrong here? See what I did wrong? Down here. So it's all to do with something here. Can you see something I did wrong in the line above? See, it was negative 3x minus 3. Even though I said divide out minus 3, I divided out 1. So I'm just going to rewrite those. So let's fix this up. So luckily we checked that. So 4x, so it's still x plus 1. But it was minus 3, x plus 1. That's what my error was. So x plus 1, 4x minus 3, sorry. So x plus 1, 4x minus 3 is the denominator. X plus 1, 4x minus 3. And then because it's multiplied, we can cancel down. So can we cancel down anything vertically? First of all, that's what I'm going to look at. Yep, in the first fraction, I can cancel 2x minus 3, 2x minus 3. That's nice. Can we cancel anything in the second fraction? Have a look. 4x minus 3 and 4x minus 3, yep, we can cancel vertically there. Can we cancel anything diagonally? So notice we have to cancel pairs, not trios. Cancel pairs only. You can't cancel horizontally, you can just cancel diagonally or vertically when multiplying fractions. So can we cancel anything else? As clearly as we can, that's why I'm picking a nice colour. So, that one. Yes, we can cancel one thing diagonally. We can cancel x plus 1, x plus 1. So try to think, what's our final answer? Our final answer, what's left behind, is x minus 1 over 3x plus 5. And that's the answer to that very tricky question. And then the next page, I've just got a little problem solving for you. So that one's done, so sorry that took so much work. Let's just save that. Next page, I've got a problem solving for you, which looks tricky, but it's not that hard. But it's quite a good one because it combines algebraic fractions with trigonometry. So now here's a nice problem solving question which merges the topic with trigonometry. And I put a clue in the SpongeBob picture, so you could tell it. So question A. The right angle triangle given, so see it's a right angle triangle, and its lengths are written as algebraic expressions. Write down expressions for cos theta, sine theta, and tan theta in terms of x. So remember, according to SOHCAHTOA, trigonometric ratios, cos theta equals, we need to also label. So here's our theta here. Which one is the hypotenuse? That's right, the hypotenuse is always opposite the right angle. Which one is the opposite? Opposite is always opposite the angle, so that's the opposite. Which one is the adjacent? It's the one next to the angle. So opposite and adjacent create the right angle. So cos theta, remember according to SOHCAHTOA, cos theta is adjacent over hypotenuse. So in this case it will be equal to, so the adjacent is x plus 2 and the hypotenuse is x squared. Lovely. Now, next one is sine theta. Sine theta, according to SOHCAHTOA, sine theta is opposite over hypotenuse. So it's going to be our opposite, which is x minus 1, over our hypotenuse, which is x squared. And the last one they want is tan theta. So I might do that down here. Tan theta, according to SOHCAHTOA, is, sorry, tan theta according to SOHCAHTOA, opposite over adjacent, opposite over adjacent, which equals, opposite is x minus 1 adjacent is x plus 2. So that's question A done. Now they want us to do B, and in B, they want us to use these expressions to verify that sine theta divided by cos theta equals tan theta. So let's set up our fraction. Sine theta is x minus 1 over x squared. So let's write that first sine. Well, you might want to write the whole thing first. Let's write it out. Sine theta divided by cos theta equals tan theta. So let's write up the tan that we're meant to set up. Then we can write the fractions underneath it, which will be a lot easier. So sine theta I've got in blue, that's x minus 1 over x squared. And let's divide. Cos theta, which I've got in green, cos theta is x plus 2 over x squared equals tan theta. Tan theta I've got in red, x minus 1 over x plus 2. X minus 1 over x plus 2. So what we need to do now is, because it's divide, we need to keep, change, flip. So if that helps, we can write keep, change, flip here. Keep, change, flip. So let's write x minus 1 over x squared. We need to change the divide to a times, and we need to flip the second fraction. So flip the second fraction, we're going to get x squared over x plus 2 equals x minus 1 over x plus 2. So we just did keep, change, flip. We changed the divide to a multiply, and we flip the second fraction. Now we can, let's see, can we do any cancelling down? So we can actually cancel down on the left-hand side of the equation. We can cancel down x squared and x squared. So if we can cancel down x squared and x squared, notice it just becomes 1 and 1. What's x minus, and then we can multiply the numerators and multiply the denominators, because we can't cancel anything else down. X minus 1 times 1 is just x minus 1. 1 times x plus 2 is still just x plus 2 equals x minus 1 over x plus 2. So we have proven that sine theta divided by cos theta equals tan theta, haven't we? So we've just proven using these algebraic fractions that for a right angled triangle, sine theta divided by cos theta equals tan theta. So we can write yes, we have confirmed, as the left-hand side equals the right-hand side. That's all we were asked to do, confirm that sine theta divided by cos theta does equal tan theta. And thank you, that's the end of the video. Save.